the little north, uh, like the east, that little horn part of Africa. Um, it got its independence from France in 1977. Hence the unusual spelling of the country's name. And yeah, it's the whole country is actually total area of the is 9,000 square miles of the whole country is just that big. All right, so what we're going to do here, we're going to, oh yeah, charging. You guys hear me now? Okay, so I'm going to give you some practice problems. So for these three questions, find the derivative. So find the derivative for those three questions. Daniel, how are you doing? No video today, just a little cartoon.
No, sorry, I forgot to turn it back on. My bad.
Lauren, where are we at today? Fullerton, Mexico, Canada.
In Las Vegas.
Oh, really? What are you doing in Vegas?
My dad recently bought a vacation home out here, so I'm just helping out furnishing.
Oh, very nice. Is it close to like what part of Vegas?
It's literally like right before the strip. Like I get off on Blue Diamond and it's on the left side approaching Vegas.
Oh, okay. Yeah.
I think Enterprise,
my
I'm not sure.
Sorry, what was the last sentence you said?
I think it's an Enterprise. I'm not aware or familiar with the areas over here.
Yeah, I'm just starting to learn it. I know my buddy said Summerlin is really nice.
Summerlin's really nice.
And then Henderson is not bad either, right?
Henderson is nice, but it could have like some bad parts. All I know is like going past the strip, like on the top right, like that's like not a good area.
Oh yeah, no, downtown Vegas area, like north. Yeah. Yeah, I was joking about Canada. You don't want to go to Canada right now unless you want to be stuck in a hotel room for 2 weeks. All right, I'll give you guys 2 more minutes, then we'll go over these. Are the restaurants open now for dining in Orange County as well?
For the most part, yeah.
Okay, but some places they just chose not to open still, right?
They usually have like the 6 feet still, like the whole policy. Cause I live in front of the block and everything's open.
Yeah, but I'm talking about places like In-N-Out. Like the In-N-Out by my house, they still has not open inside. It's just takeout.
Then no, they haven't opened.
So, how many of you are done or done trying? Okay, I'll give you guys 1 more minute, 2 more minutes. Oh, Taejun, I didn't know you were here this whole time. I just noticed your head. I thought it was just the empty room. Okay, let's go over this. So the first one, that's a product, right? When you see something times something, so the main function here is a product. So the derivative is first times the derivative of the second. What's the derivative of cosine? Negative sine. Times the derivative of the inside, which is 4. So that's first times the derivative of second plus second times the derivative of first. What's the derivative of e to the negative 2x? Well, it's itself times the derivative of the exponent, which is negative 2. So this is first, derivative of second, oops, times the derivative of first. Now, I would clean it up a little bit. I like to put the negative 4 like that together, sine of 4x, e to the minus 2x, minus 2 cosine 4x, e to the negative 2x. And you could you don't need to factor out, but you could write the e to the negative 2x before the trig function, either or. But I would just stop right there. How many of you got that? Or something close to it, equivalent to it, I should say. Not close to it, but equivalent to it. All right, this next one is actually even quicker. The derivative of an exponential, this is an exponential function, 10 to the something, is itself chain rule times the derivative of the exponent, negative 2x. And that was pretty much it, but because it's not base e, it's base 10, you got to go times ln of 10, and now we're done.
Professor,
Yeah.
how are we supposed to know when to use chain rule and product rule? Like, are we just...
Well, when it's a product, you use the product rule. So this is a product, so you use the product rule. Chain rule, you always use the chain rule.
Okay, thank you.
I mean,
you
can think of it as like this, like, I'll come back to the first second. Like, if I say what's the derivative of x to the fourth, you say 4x to the third, times the derivative of x, which is 1. Bothering the derivative of x is 1. We just say it works here. But let's say if it was, now you have something like this. X squared plus 5x to the fourth. If you're taking the derivative of that, well, it's 4 times that something to the third times the derivative of what's inside. This is like u to the fourth. So 4u to the third times the derivative of u, which is 2x plus 5. So that's the chain rule there. Notice on top here, we use the chain rule because it's just, it's 4 times x to the third, and there's just x. Here it's something more than x. We call that u. Like inside here, this parentheses, that's the u. So it's 4. When you have u to the fourth, it's 4 u to the third, and then times the derivative of u.
Thank you.
Okay, so now going back up here, so in this case, it's 10 to the u. So the derivative would be 10 to the u times u prime. Okay. This next one, then this is a tangent function. The main function here is a tangent of something. What is that something? That red box is something, the u. So if I were to say, what is the tangent, the derivative of tangent of u? You would say it's secant squared of u times whatever the derivative of u is. That's the chain rule. So going back to this problem right here, what's the derivative of tangent? Secant squared of u times the derivative of u. Well, what's the derivative of natural log 5x plus 7? Well, that means 5x plus 7 goes on the bottom, whatever you're taking natural log of, and it's the derivative of 5 goes on top. Does that make sense? So remember, the answer is not, this is not tangent times natural log. So a lot of people on the last list make this mistake. They say, oh, tangent times log. Well, we didn't have log on last list, but you know what I mean. Tangent times something. So tangent, derivative of the second one is tangent of that. Tangent by itself means nothing. You can't just say tan. The only time you say tan is when you're trying to get a tan. That was a bad joke. But it's tangent of something. Yeah, something has to come after it, whether it's x or a number or something. It's like just saying tan by itself is like me writing a square root symbol all by itself. It means nothing. You have to have something there. So you never write ln by itself. It's always ln of x or ln of some number. Same thing with the trig functions. Same thing with radical. Same thing with limit. Always has to come something. Don't ever say limit equals. Limit of what equals? Limit of x, limit of some expression. You have to write something after limit. You have to write something after a trig function. You have to write something inside a radical. All right. Let's practice logarithmic differentiation. I don't know if you did this one already, but it's good practice anyway. Y equals x to x. So even if I didn't tell you to use logarithmic differentiation, you'd know you have to use it here because look, it's not a power function. Like x squared, x to the third, x to the fourth, those are power functions when it's x to a number. It's not an exponential function. It's not 2 to the x or e to the x or 4 to the x. It's not a number to an x. It's variable to a variable. So it's neither a power function or an exponential function. So well, you don't have to think too hard. The directions say use logarithmic differentiation, so just use logarithmic differentiation. By the way, did you guys have any questions from the inverse trig function problems? You want me to do one of those? If you have one, pick one for me to do after this question. Oh, hold on. I stopped looking at the chat. Hold on. Oh, 10 to the 1 minus x squared. That's the answer. Oh, thanks, Elia. Yeah, you answered. All right, how many of you are done? So we're going to take the log of both sides, right? ln and ln. So you got natural log of y equals, that allows us to bring the x downstairs, x times the natural log of x. So we're going to take the derivative of both sides with respect to x. So what's the derivative of natural log of y? Oops. Well, you're taking the natural log of goes on the bottom. Its derivative, the derivative of y is y prime, equals. The right side, we've got to use the product rule because it's a product. First times the derivative of the second plus second times the derivative of the first, which is 1. So notice here, these x's cancel out. So I'm going to multiply both sides by y. So y prime is equal to 1 plus ln of x times y. Replace y with what y is equal to. That's the original problem that I wrote in blue, which is x to the x. And there we go. That's it. All right, since no one is asking a question on an inverse trig problem, let me get to that section and pick one. What section was the inverse trig? I'll look at my. Was it in the same section as trig functions 3.3? Or I don't remember. No, it's got to be way after that. Is it implicit differentiation 3.5? Huh?
I think it's on 3.5 with implicit differentiation.
Oh, okay. Oh, yeah. Okay, there you go. Yeah, the other book that I use in the other college, it's ordered a little differently. It's a whole section on just on implicit differentiation. All right, there it is, 49 to 53 that I said. Okay, let's do this one. Let's do number 49 from the homework. So section 3.5, number 49, which is y equals the inverse tangent of x, whole thing squared. So hopefully you already attempted this. Oh yeah, you wrote 3.5 in the chat. I wasn't looking at the chat. So what kind of function is this? This is the main function here. It's a power function. It's something squared. It's not an inverse tangent function. The inside function is inverse tangent, but right now we're talking about the main function. It's u squared. So the derivative of u squared would be 2 times u. That's the power rule to the first power, times the derivative of u. Now times the derivative of the inside function. What's the derivative of inverse tangent? It's 1 over 1 plus x squared. And you have that handy if you look at your inverse trig. So focus on remembering the trig functions and their derivative and the inverse trig functions. I'm already being pretty nice. I eliminated the hyperbolics for you and the inverse hyperbolics. I can see some professor making you memorize all 24 and having proctio where your eyes is like has to be looked at through the camera and you can't scan the room and you have to have all 24 of them memorized. I don't know if any professor makes you memorize the inverse hyperbolics. The hyperbolics I've heard some professor make you memorize, but not the inverse hyperbolics. Oh yeah, let me know if you've run into one. All right, any questions on this? All right, let's do number 51. Y equals the inverse sine of 2x plus 1. All right, you guys do try to do this first. So just to remind you before I do this question, remember when you're taking the derivative of the inverse sine of u, the derivative is going to be 1 over square root of 1 minus u squared times the derivative of u. That's the chain. For this case, your u is 2x plus 1. Does that help? All right, you guys got some studying to do. If you, some of you look like you're a deer caught in the headlights. Maybe that's just how you naturally look. No, I'm just joking. Sorry. Here we go. Y prime is equal to 1 over the square root of 1 minus u, which is 2x plus 1 squared, times the derivative of 2x plus 1, which is 2. And that's pretty much it. You don't need to expand the bottom. Just leave it. You can leave it like this. No, I'm curious. Does the book expand the bottom? There's no reason to. I'm just really curious what the book decides to do on this as the answer. But you could leave it the way I wrote it. I mean, I would put the 2 up top, but that's about it. (3.5), number 51. Oh, the book actually keeps going further on that one. That's fine. All right, you guys want to do one more, or you want to call it a day? I feel like the energy has been taken out of you two, after these two problems.
Let's call it a day.
No, can you do one more, please?
Let's do one more here. I'll make this one up. Let's go with y equals the inverse tangent of x to the third. So I'll give you the hint. If you're taking the derivative of the inverse tangent of u, the derivative would be 1 over 1 plus u squared, but then times the derivative of u.
Professor,
Yeah.
for on the textbook on the page 214 that you mentioned, for the inverse trig functions, there is no u to u prime that you multiply it by.
Well, yeah, because they're not showing you the chain rule. They're showing you the basic ones. Like when I went over 3.5, that's what I showed as well. That's if you have an x. But if it's a u, you got to use the chain rule.
So if it's just like x to the power 1, then it wouldn't be there because it would turn into 1, I'm guessing.
Yeah, exactly. So what they're saying is, and I wrote it like this: y equals tangent inverse tangent of x. Yeah, then the derivative would be 1 over 1 plus x squared, and you're done. But I'm saying, what if it's more than x? It's something like x to the third. Then you got to come back and take the derivative of that. That's the chain rule.
All right, got it. Thanks, Professor.
So yeah, I think when I went over it the first time, I did what the book did there. I just wrote it in terms of x. I didn't want to throw the u's at you. But now that you had a chance to practice it, well, 10 of you practiced it, then now you got to be able to, you got to apply the chain rule as well. So really, I almost forgot you were here. Thanks for asking a question. All right, here we go. The derivative is 1 over 1 plus x to the third squared times the derivative of x to the third. Some people do this. They go times the derivative of x to the third. No, just tell me what it is. 3x squared. Come on. You don't have to write another line for that. All right. 3x squared over 1 plus x to the 6th. Because when you raise the power to another power, you multiply. And there we go. How many of you got that? Very good. All right. So let me tell you the sections the test will be on before I run out of time here. So here's the thing. A math class is always naturally cumulative, even if I say the test is not cumulative, because will you have to know the power rule, the chain rule, the product rule for this test? Of course you do, even though it was stuff you got tested on the first test. So, will you know how have to factor? Of course you need to know how to factor. So you have to remember your 9th grade algebra. So a math test always involves stuff that you've previously learned. Having said that, I'm not going to ask you something very specific from the first test. Like I'm not going to ask you on this test, take the limit definition of derivative. Use the limit definition of derivative. That's like specifically was exam 1. And then it'll come back on the final when we cover everything. But so even though the first section that we did after the test was 3.5, I believe, which was implicit differentiation, I'm going to throw 3.4 in there too, which is the chain rule, because you really got to know the chain rule. 3.5 and 3.5 was implicit differentiation. 3.6 was derivative of logs. 3.9, which was related rates. Remind me, we can do more related rate questions. The answers are on Canvas. 3.10 was differentials. 3.11 was hyperbolics, but I told you I'm not going to put it on the test. You're welcome. And then 4.1, which was max-min problems that we just did on Tuesday, which was, critical numbers, absolute max, absolute min. And then 4.2, which is the mean value theorem, which we covered today. So we can ask you questions on 4.1 and 4.2 next time as well. So these are the sections that will be on exam 2. So study those. The review sheet is not that many questions. I'll post it by tonight or tomorrow morning at the latest. Just make sure you want extra practice, you go to the homework in these sections and pick a few problems to do yourself. And then, you know, you can ask me about it if you run into trouble. You got Aaliyah that has her study session, so look for her emails, and then also Math Lab. All right, are we good? All right, I'm gonna go get dinner. I'm hungry. See you guys. Bye.
Thank you.